Welcome everybody. As they mentioned, I'm Eric Bowen. I'm Director of Product Development at Novilytic. I'm here to discuss with you today the analysis of IgG Biosimilars using the Proteometer-L kit. So today we're going to discuss a little bit about how the Proteometer-L works. I'll share with you some separation examples, and I'll share with you some separation reproducibility data. This is a typical mAb purification process. We start out with filtration, followed by protein A purification, chromatographic polishing steps, followed by product analysis using either SCC-UV or mass spectrometry. The difficulty with this process is that it's very time consuming and it costs a lot of money in order to do this, and it takes a lot of time, meaning that you don't get a lot of real-time data for data-dependent decision making. So what we've developed is something called the proteometer, or the Proteoform Meter, which provides an early warning of problems with mAbs by allowing data analysis without having to do any of the protein A purification or sample preparation steps. The intact molecule is analyzed rather than the mAb being denatured prior to doing the analyses. The process can be run at any time throughout the purification process, and then the net effect with that is that we get more accurate results than typical analyses without having to use the protein A or any of the other sample preparation steps. And here's how it works. So we have a third phase in our separations, a mobile affinity phase, which is a small nanoparticle bound to a fluorescent affinity selector. So after we make the injection of the mAb, it then passes through the mobile affinity selector as it's passing through the column. The bands then selectively bind to the antibody, and then it begins to separate by size, and it continues on through the column, washing as it goes because it's being immersed in the mobile affinity selector the entire way through, followed by fluorescence detection. At the end, because the affinity selector is selectively bound to the antibody, the remaining host cell proteins in solution are rendered invisible to the detector. So we see only the antibody and the aggregates coming out. And here's how that works in process. So as I mentioned, we don't do any sample preparation steps at all. We just run this on the clarified fermentation broth. Our tests take just 10 minutes to run, where traditional methods can take anywhere up to 8 to 24 hours in order to run the data. And we quickly and accurately determine the titer and the aggregate content for the mAb. If you take a look at the chromatogram on the top left up here, you'll see that this is what an unpurified sample would look like in SCC-UV. You can see there's quite a few peaks in here from the host cell proteins. Our aggregate peak is this small peak here, and then the monomer peak is here, but it's very difficult to be able to quantitate that. So how would we do that? Well, if we use the Proteometer-L, as you can see at the bottom, we get that the separation that I previously mentioned. So we have a nice crisp aggregate peak here, followed by a monomer peak. We get a little bit of fragmentation data coming out here between 4 and 6 minutes. And then we get this trough out here about 7 to 8 minutes, which results from the withdrawal of the fluorescent affinity selector from solution as it's being bound to mAb. So we get some additional data out of the chromatograms as well. If you notice that the peak for the monomer is much larger than the peak for the trough, we get some fluorescence amplification occurring during the separations. In addition, the width of the trough peak corresponds to the on rate of the fluorescent affinity selector to the mAb. So the wider we go, there's more affinity for the mAb. If you notice up here in the top right-hand side, you see we get a stoichiometric ratio between the proteoforms here and the fluorescent affinity selector, so for the monomer and the dimer and the trimer down here. And in addition, we could actually add additional fluorescent affinity selectors here, which means we could actually do multiple assays in one chromatography run. So here's what this looks like in practice. Here's the NIST monoclonal antibody. And as you can see here, we have a nice aggregate peak here, the monomer, the fragmentation data, as I mentioned out here, between 4 and 6 minutes, and then the trough with increasing amounts of material. We get a wider and wider trough on this. We have a linear response here between 0.5 and 16 micrograms of NIST-mAb injected on the column. And that's going to be dependent on your lamp energy and your system age. In addition, we don't get any host cell proteins that are showing up in the detector. But who actually runs the NIST-mAb? Not very many people. So we want to look at biosimilars. So here's an IgG1 right here, and as you can see, as previously, we have an aggregate peak here with a dimer and possibly a trimer out here as well. We have the monomer peak as before. We get our fragmentation data right here. We also get the trough peak that we had seen before, and also a linear response for this, again, between 0.5 and 16 micrograms injected on column. And it also works for IgG2s the same way, and IgG4s the exact same way. As I mentioned, of course, with the linear responses up top here, but I also wanted to share with you some reproducibility data. So here at the bottom, we have reproducibility data run by 2 different analysts on 2 different days on 2 different reactors on 2 different systems. And we ended up getting an RSD of 5% or less for the aggregate data over each of these. So the analyses are highly reproducible and very automatable. The analysis also works with FcγR receptor deficient mAbs, as we can see here, with the aglycosylated cetuximab over here, the Fc silent cetuximab over here, and tislelizumab over here. We get very low aggregate contents on each of these right here. The aglycosylated cetuximab was a little bit lower, which means we end up with a little bit higher percent RSD on that one. But this is very important because these types of drugs are used in oncology. We also get highly reproducible results over more than 1,000 injections for each reactor that we've run. Some customers have actually taken it up to 2,000 injections now, with less than 5% variability in the total peak area across that entire range. And our retention times are rock solid along that same time range as well for both the monomer and the aggregate here. And that's despite making consecutive injections of fetal bovine serum interspersed throughout these analyses to try and really gum up the reactor column if we possibly could, which we weren't able to. The analysis is also highly reproducible from reactor to reactor. Here are 15 different injections, 1 from each of 15 different proteometer reactors. And as before, this was done on separate systems, separate days, separate analysts, and we get very rock solid aggregate data, monomer data here, and our fragments again between 4 and 6 minutes roughly, and then the trough. There's a little bit of variability in the trough retention time here, and that just has to do with column packing issues. So in summary, the Proteometer-L, it delivered linear, accurate, and repeatable titer and relative aggregate percentage results for the IgG1s, IgG2s, and IgG4 biosimilars, all in clarified fermentation broth without any sample preparation at all. So the reactor to date has worked with every human and humanized mAb that we've tested. It's also worked with Fc-gamma receptor deficient mAbs, bispecifics, and even a few selected animal mAbs. The results that we saw showed excellent reactor-to-reactor reproducibility and tested on multiple HPLC systems with multiple analysts over multiple days. So at this time, I'd like to thank the following individuals right here for making this possible, including Dr. Fred Rainier, and then these other individuals here, all of whom contributed to the process and allowed us to get the product out that we see today. Thank you very much.